Hi everyone. So we have a good question from the chapter of simple harmonic motion. So let's go through the question once to understand the information which has been given in the question. So the question says that a block of mass m has been connected with three massless springs and a massless pulley. The springs are initially in natural length. The surface is smooth, which means there is no friction. The block is slightly shifted towards the right, and then it is released, and therefore we now have to find the time period, right? So let's understand what's exactly happening over here. Say we have moved this block slightly towards the right, like this. Okay, as you can see, these two springs, they are getting compressed, right? They will exert a force towards the left, right? It's quite obvious. Similarly, we have got a spring over here which is being uh, stretched, right? It wants to get back to its natural length. So the spring force again is towards this direction, right? Now, as for this string over here, this string, when it is stretched, it will be in tension, right? The tensional force will again be towards the left. So this is what happens when the masses move towards the right. But now we know after it is released, because of the force, it will gain acceleration, it will reach a midpoint. And then when the acceleration becomes zero, because of some kinetic energy, it will again move towards the left, right? Let's see what happens when it moves towards the left. And this is the more important part, okay? I'll tell you why. See, we have this block over here. This spring is stretched, right? So it wants to get back to its natural position. Hence, the force of the spring will be towards the right. This spring right here, it is stretched. I'm sorry, it is compressed, and it wants to give a force towards the right as well. But in this case, this won't happen. Why? If you see this over here, uh, we have a string over here, right? When we are moving the block towards the left, that string which connects the massless pulley to the block, that that is no longer taut, right? So it may. So I hope you are able to understand that uh, since it's no longer taut, this will no longer be able to exert a force towards the right. Okay, and in that particular case, only these two springs will be in action. Okay, uh, yeah. So let's start with the calculations now. I have drawn a diagram for you over here. So let us assume that these two springs over here, they are being compressed by a length of x naught. Suppose. Okay. So what is the okay? Let the tension in this particular string over here, let this be T. So this is T by 2 over here, and this is T by 2, right? Now this uh, spring over here, it is moving by a distance of x naught. This spring over here, it will move by a distance of 2x naught. Why? Because forces have to remain constant, right? So it's in the I'm very sure you must have studied this in Newton's law of motion. Okay, this displacement will be 2x naught. I'm not going to show you the derivation. It's very easy. So anyways, so now let us equate the forces. T by 2 is equal to K 2x naught. Okay. So the value of tension is equal to 4K x naught. All right. So when this body over here, this mass of mass m, when it is moved towards the right, what happens is that the net force will become 4kx plus 2kx. The 2kx is because of these two springs over here. Okay, it's because of these two springs. And minus, well, you can say that it's pushing it back, so it's minus. Okay, it totally depends on the sign convention. Okay, so this will become minus 6kx. This is equal to ma. A will become proportional to m, right? I'm sorry, a will become proportional to x, right? So you can say that the time period 1 will be equal to 2 pi root m by 6k, right? This is the time period 1. Actually, it's not. There's a small error. It will be divided by 2 because 2 pi matlab the entire circle, right? It means it indicates the entire length of that SHM. Okay, the entire amplitude of that SHM. Right now, this particular block, it has only covered one half of it, so it will be 2 pi by 2. Okay, so it will be pi m divided by 6k under root. Okay, now I don't think it will be very difficult to find out what the f net towards the left will be. So f net when the body moves to the left, it will become minus 2kx. Okay, why? Because only the springs are in action. Okay, there's no need to take into account this entire system over here towards the left. No use, right? So the time period will be again 2 pi by 2. This will be root m by 2k. So the total time period will be m under root m by 6k plus pi into under root m by 2k. So yeah, you have got your answer, right? You have. This is your answer. Okay. So the key takeaway is that you have to understand that the properties of spring and strings are different. Okay, they behave differently when they're compressed. A string loses its tautness when it is moved, when it is compressed. Okay, and that is the reason why this particular spring over here, it becomes useless in the second case. Okay, thank you.